We're studying IGCSE chemistry and we're starting chapter 9, reversible reactions and equilibrium. Now, this is the first class on it. And what is this class all about? We'll be learning all about Equilibria. The following things. We'll be learning about what are reversible reactions, what is equilibrium,
Okay.
Factors affecting equilibrium, we'll also be learning about Haber process, contact process, and finally fertilizers. Okay, first, Niranjana, tell me, what have you studied in chapter 9? Have you finished the whole chapter in school?
Yes, sir. Not the whole, but she took most of them.
Okay, so which of these have you heard in class? Which of these have you not heard in class?
She just revised that fertilizers and everything contact process on last Tuesday. It was our last day, so she just started.
All right, okay, fine then. So everything is there. So let's start. Now you should be able to see both the book and the whiteboard. Yeah, good. Now, what device are you using? Your laptop?
Yes, sir.
That's good. Let's start now. Start from here. Start reading. Actually, you don't have to read that. I want you to read. Okay, all right. I'll just show you some stuff. Now, Niranjana, what do you know about reversible reaction? What are they? What are reversible reactions?
It can be reversed to its back, like the product can be reversed and turned into the reactants.
Yeah, that happens. Yeah. So first, if let's say, let's say I'll show it to you.
So why are you showing the picture of you?
I'll tell you just a second. If you look at these two people, right? If you look at these, now one thing is, when you have a reaction like this, perhaps you're making an egg, right? That also involves chemical reactions. You heat it up, you put the stuff in, everything joins together. Cooking is chemistry, yeah. So this reaction on okay, if you make an egg, let's say if you make an omelette with an egg, can you get the egg back after you have made the dish? Yes, no,
Oh.
no. But if you melt water, can you freeze it again?
So can you repeat, because my internet was slow and you
Yeah.
was lying.
If you melt water, if you melt, let's say if you melt ice, can you freeze it again?
Yeah, we can.
So in that, so what we realize is that this guy over here is called a reversible reaction because it can be reversed. It can go in the reverse order. But on the other hand, this is not a reversible reaction. It's called an irreversible reaction. Okay. We don't really care about these guys, but we care especially about this. Now, what does this look like? What happens is you have ice and you'll have water. Now, okay, this is not a reversible reaction. This is just a reaction, which is telling us that the reactant is ice, yes? And this is the product. Now, what we realize is in reality, this is what the equation looks like. Now, you don't have to write this right now. I'll give you a better example in a second. This is what it looks like. Now, this symbol right here is used for reversible reactions. Okay. Done. Okay. Now I want you to write some things down. First things first. Okay, first things first. Let's see. Now, what is an equilibrium? Niranjana, what do you know about equilibrium?
When two things are in the same level.
All right. Let's see. If you have NH force here, just a second. Let's say you have N2 or N2O4. Now, this right here is another reversible reaction. Now, what are the reactants here? The reactants are nitrogen and oxygen. The product is nitrogen oxide, right? Nitrogen dioxide. And that's what you're getting. What happens is, if let's say in reversible reactions, what happens is from here to here you can go forwards, but at the same time some of the nitrogen N2O4 is also turning back into nitrogen and oxygen, while some of them are going forwards, right? So both of these are happening. Some of them are joining together to become N2O4, and some of the N2O4 is going backwards to break down into nitrogen and oxygen. Now that's happening. But what happens is, let's say sometimes when you start this, let's say you put 100 of these, okay, 0 of these. Now what do you think? Is the reaction going to go forwards or backwards? You have 100 of these people, let's say 100 of N2, 100 N2 molecules, you have 100 of oxygen molecules. What happens is at the beginning, these guys will keep going forwards. Let's say the forward reaction will be a bit fast because we don't really have anything here, so it won't really go backwards because right now at the beginning it's 0. Now what happens is, let's say now the half of this is used up, and this becomes 50. Now what happens is this starts going backwards as well. N2O4, it was forming, now it's also going backwards. So both of these are now, let's say this becomes slow and this becomes fast. What we need to realize is, let's say, just a second, I'll tell you. If you have any reaction like this, okay, after some time, an equilibrium is established. And I want you to write down what is an equilibrium. Get your notebook and start writing.
Okay, sir.
Write the whole thing.
It is all?
Yes. There are 2 points, 1 and 2. And these are about 4 marks in the exam, 4 to 5 marks. Just a second. In the last part, you should write a constant.
So
A constant. At the end, write this line.
sir, can you show the thing for equilibrium and maintenance product up? Sir, can you scroll a bit up? I want to see this.
Can you see it? Now this right here is all you need. Have you written it down?
Done.
Done?
Yep.
Any questions here?
No.
Now, okay, what I mean by equilibrium is, see, that there are two kinds of reactions happening. First, we have a forward reaction, okay, which is going forward. This arrow, the up one tells us going forward, and in the bottom one, that tells us going backwards. Now, if you leave a reaction for some time, let's say at the beginning, what happens is, at the beginning, if you put a lot of these guys, let's say a lot of reactants, then this will be fast, okay? But what happens after some time is that these guys both become equal. Or let's say both become, let's say, same speed. Forward and backward after some time. So what that means is the forward reaction is happening and the backward reaction is happening at the same speed. So at the start, it wasn't happening. At the start, what we had? At the start, the forward reaction was fast. Just a second. The forward reaction was fast. But after some time, if you leave this reaction to be in a closed system, then what happens is that both the forward and backward reactions become equal. The speed becomes the same. So after some time, the speed becomes the same. Okay, let's continue. Now, the next thing we have is to talk about what things affect this equilibrium. And Niranjana, what have we seen about equilibrium? We have seen that rates of reaction of forward and backward reaction are same, right? The rate of reaction is equal, forward and backward, and the concentrations remain the same. Okay, fine. What are the factors affecting equilibrium? The factors
Temperature,
affecting,
concentration,
yes, temperature, concentration,
volume.
not volume, pressure.
Then
Well, volume and pressure are the same thing. They're together. And let's say there's another one, which is,
so should I write it?
yes, you should. These three.
Only these three?
Yeah, these three, nothing else. Now we have another thing called, let's say, a catalyst.
So they work best when they are in powder form, right?
Which catalyst?
Like the reaction speeds up when they are in powder form, right?
Yes. So have you done rate of reaction in class? Is that coming in the test?
She just said chapter 9 is coming.
Chapter 9. So that's, I think chapter 8 is rate of reaction. We won't be focusing on that, but yes, if you have any reactant powdered form, gives us more surface area, so it's faster. Let's focus on this first. Now, have you written this down?
Yep.
Now, for catalyst, you need to write no effect. Catalysts don't have an effect on equilibrium.
Why? Catalyst speeds up the reaction, right?
They speed up the reaction, but they don't change. I'll tell you what equilibrium means in a second. How equilibrium is changing. In a second, let's see. Now, if I have any reaction, let's say,
Catalyst does not affect.
no, does not affect equilibrium. It does affect rate of reaction, but does not affect no effect on equilibrium. On equilibrium.
Done writing.
Then writing. Now let's focus on one of the main important things. Let's say, let's start with Haber process. Now we'll look at all of these things in Haber process. Okay, so Haber process. Or before we do that, let's take another example. Perhaps an example of N2 or let's say, yep, this is fine. N2 plus 3H2 gives us 2NH3. Now this is an example. Now what are we doing in this? What we realize is this is a reversible reaction because I have this symbol right here. That tells me that the reaction is going forwards and backwards. So this guy is saying these guys are joining to make this, while this is also breaking down to make this again. Make the reactants. Is that clear? So now you'll know a few things about the reaction already, which will be given in the question. You will be given that this reaction, let's say, is endothermic. Sorry, exothermic. All right, Niranjana. Now, the first thing first, we'll look at temperature. How does temperature affect an equilibrium? Now, one thing you need to realize is, in an equilibrium, it is not necessary that both the reactants and products are in the same, let's say, quantity or same amount. What may happen is, perhaps you have a lot of these guys left at equilibrium, about this much of nitrogen, this much of hydrogen, but only this much of ammonia is produced, right? So they don't have to be same. Let's say this is the amount of nitrogen we have at equilibrium. This is the amount of hydrogen we have, but this is the amount of ammonia we have. Now this right here is ammonia, right? You know that. Fine. Now what really happens is, before I look at temperature, let's look at concentration actually. Concentration. Now let's say if I increase the concentration over here, if I increase the concentration of the reactants, what will happen? If I, let's say, if I make more of these guys suddenly, a lot more, then what will happen to the equilibrium? See, what we know that equilibrium is only there when we have concentrations to be constant. Now, if I change the concentration, if I increase the concentration of, let's say, nitrogen, at the beginning it was this much. Hydrogen was this much, and nitrogen was this much. But now, if I change it, let's say I make nitrogen this much, hydrogen this much. what will happen to the equilibrium? Now, any guesses? Now, what happens is if I increase these guys, then more of these will react to form this. Okay, if I
Yeah.
increase these guys, then more of this will form to more of these will react to form this. So I'll write this down in this, over here. Just a second. Now I'll write it here. If I increase the concentration of N2, let's say reactants, then more product is formed. Okay. Now, Niranjana, what happens if I increase the concentration of, let's say, the products? What happens is that more reactants will react. Now, Niranjana, I want you to read this first. Start from here.
Okay. Increase the concentration of reactants, more products is formed, more reactants will react, increase the concentration of products. So can I write it down?
Not right now, just a second. Try to understand what's happening. Now, if you increase the concentration of these guys, okay, suddenly you have more of the reactants. So now more product will form. Yeah, this is how it's going. But if I increase the concentration of the products, okay, sorry, if I decrease the concentration of the products, then more products, more reactants will react. Okay, now the thing is, you need to write this down. Just a second. Something called the Chatelier's principle. First, write this down. I'm giving you the definition. Just a second. Write this in your notebook.
I have to learn it by heart.
Yes, this is another definition for 3 marks.
So should I write the more reactant will increase,
Not right now.
decrease the
I'll tell you when to write it. And Niranjana, whatever definition I'm making you write, these are very important. You have to memorize them by heart.
Okay. So this person is a scientist.
Say that again.
This person is a scientist.
Yeah. Now, how do you pronounce it? Tell me his name. Read this word. He's a French scientist. Now, okay, when I was in IGCSE, I used to say Le Chatelier. Now, that's not the correct pronunciation. Why? Because this guy is French. Okay, and his name actually is Chatelier. This is a Shah. Le Chatelier. That's how you pronounce it. Le Chatelier's principal. He was born in 1800s, 1800 something. Now, have you finished writing this? Quickly.
In the last section.
His name, his actual name is actually this. No, you don't have to write this, obviously.
So then why another name?
This is his full
Noted
name.
high.
And you know how they how they pronounce it? They say Henri Louis Le Chatelier. That's French.
You learned French?
A little. Chatelier. Done.
Yep.
Okay. Now the important thing here is, now let's see how is this rule being played out here. Now see, the first thing, this is the change I'm making. This change is the one which I'm making. Okay. Now what am I doing? Read this out. Just this part. Increasing the reaction concentration. Read it. Ranjana, can you hear me?
Yeah, I can hear you.
So read this out on the board.
Okay. Increase the concentration of reactants, more products are formed.
Yeah, so you don't have to read that now. Read this again. Increase the concentrations of reactants. So what's happening? What change am I making? Now, if I change the constant, the concentration is changing, yes? So if concentration is changing, then it cannot be in equilibrium now. So as concentration changed, reaction is no longer in equilibrium, is no longer in equilibrium. Why is that, Niranjana? Can you tell me? Why is it not in equilibrium?
Why?
Read the second point here. Read it.
The concentration of reactants and products are constant.
Constant. Now, if I increase it, it's no longer constant. Yes, I've increased it. So it has changed. And the whole point was of equilibrium was that concentration cannot change, or it's constant. So if I change it, then it is no longer in equilibrium. Yes, makes sense.
Yeah.
Now, okay, now I'll tell you the result of this. As a result, what happens is, okay, you tell me, Niranjana, if I give you, let's say, let's say, you had a box here. Okay. Now, at the beginning, inside the box, we had these many balls or marbles, right? And afterwards, I added two more. Now, if I add two more to this box, how can let's say at the start it was three. Then I made it five. Now, how do I make it to three again?
By reducing them.
Reducing them. So what I'll have to do is either I'll have to remove any two. So then I'll have to remove this guy. The extra part, with whatever came extra, I'll have to remove him. So that will go back to three. Right? That's what happened. So first it was like this. Okay. It was like this. Then what we do is we remove the extra stuff and we come back to three. So this was at equilibrium. Okay, we had three. This is constant. We have three particles inside the box. But then if I increase it, no longer equilibrium. Why is it no longer equilibrium, Niranjana?
Because they are not constant.
Not constant, yes, because the concentration has increased. And how do I make it go back to constant? I'll have to
Remove
reduce the
the
particles, remove the extra stuff, whatever extra came, remove it. So we go back to equilibrium. Making sense? Now what we do here is, in the same way, if I increase the concentration of reactant, what will I have to do to reverse that thing? Let's say if I increase reactant, what is the opposite of increasing reactants?
So can you repeat your words?
I'll repeat your question. If let's say if I increase the reactants, what is the opposite of increasing reactants? What is the opposite of that?
The products will increase.
Just be no. Let's do this. That is true. The products will increase, but I want you to look at it in a different way, a simpler way.
Okay.
If reactant is increasing, then opposite is reactant decreasing.
Yeah.
Yes. So that is exactly what is happening here. If you look here, actually, before we look there, let's try another one. If reactant is decreasing, what is the opposite of that?
Decreasing.
What is the opposite of reactant decreasing? Reactant
Increasing in the product side.
increasing. So this is the change happening, the opposite, which is also your result. Let's see how this plays out in real life. Now, if I increase the concentration of reactants, then what do I have to do? I have to decrease the concentration of the reactants as a change. I have to do the opposite. And that is exactly what happens. As more reactants, as wait.
Yeah, sir.
Now what were we learning? We realized that whatever change I make, the reaction will do the opposite of it. Is that clear? Say it back to me.
Yeah.
Whatever change I make, right? Whatever change Niranjana makes, the reaction will do the opposite. Say it to me.
Yeah. Whatever change I make in the reactants, the opposite change will happen in the product side.
Not the product side, sorry, not like that. Whatever change I make, right, to the reaction, not the reactant, but to the reaction. I'll write it here for you. Read it out. Whatever change we make to reaction, the reaction will do the opposite of it. Or let's say to equilibrium. Now read this out, or write this in your notebook. This part.
Whatever change we make in the reaction equilibrium, opposite the reaction will do the opposite of it.
Read it one more time. Write it in
Whatever
your notebook.
change we make to the reaction equilibrium, the reaction will do the opposite of it.
Okay. Sure. Makes sense. Have you written this down in your notebook? This is the summary of Le Chatelier's principle. Le Chatelier's principle. Right here.
Okay. So the screen is yeah.
Now you don't have to memorize this. You have to memorize Le Chatelier's principle. But this is what it means, right? Please write it down.
Yeah, you just give a short description about it.
Yes. So make it make sense. I hope it makes sense. Yes.
Yeah.
Now, okay. Now write it down quickly. We'll look at. I'll tell you all the three changes which are happening.
So I wanted to practice more in the balancing the equation and everything. Constantly.
Balancing equation. Yeah, we'll do that. But today, forget about everything. We're going to practice a lot of questions of equilibria. Now, if I give you some questions right now, will you practice them?
So related to what?
Say that again.
So related to what?
To equilibrium.
Equilibrium, I will try.
No, actually, first write this down. Tell me when you're done. Finish. Let's continue.
Okay.
Done. Let's continue. Now, the next thing we have is example 2. Let's take the example of again of N2 plus 3H2 gives us 3NH2, 2NH2. Yep. Now this is what we have. We know that this reaction is exothermic. Okay. Now write these down for the concentration. Now we're doing the first factor. Factors affecting equilibrium. The first one is concentration. Now, in concentration, we'll do the first one. Let's say increasing concentration of reactants. Now, Niranjana, if I increase the concentration of reactants, what opposite change will the reaction do? If I increase these guys, what is the opposite of increasing these?
Decreasing.
Decreasing these, yeah. If I increase this, the reaction will want to decrease this, right? Because it wants to go back to original.
So it's like when you increase one side, the other side will decrease, and when you increase the other side, the opposite side will decrease.
Yes, the same thing happens. Now let's say if I want to if I want to decrease this, let's say, then this will have to increase. Okay. So if I increase more reactants or more increasing concentration of reactants, then what happens is more products formed to reduce concentration of reactants. Now write this in your notebook. Tell me when you're done.
Okay.
Now, Niranjana, how? Okay, while you're writing, write it down and speak to me. How can you increase the, let's say, decrease the concentration of the reactants?
So can I repeat?
How can you decrease the concentration of the reactants?
Increasing the product side.
Increasing the products, right? So if perhaps you want to decrease this guy, then you'll have to increase the other one. If you want to increase this, then you have to decrease the other one, right? That's clear? Okay, now that's fine. Good. Now write this down and I'll give you one more. More products. Let's say
So I have to write the part two over here.
Yes. Done.
Done.
Done. The next thing is pressure. Sorry, not pressure. We'll look at that. That's also there. First, let's look at temperature. Now, Niranjana, do you know what endothermic and exothermic means?
Endo means they absorb heat, exo means release heat, right?
Releasing. Yes. So endothermic means absorbing heat from surrounding, and this guy means releasing heat to surrounding. Now you tell me which of these feel hotter or colder.
So what?
Endothermic feels cold. If you touch an endothermic reaction, it will feel cold. Is that clear? And
I will write it.
write this down. That's just a recap.
I want to ask you one thing. If we make spelling mistakes in IGCSE, will they cut our marks?
In English, yes, 1 mark for each spelling mistake, half a mark for each spelling mistake. And that's what the examiners have told me. But for physics, chemistry, nobody cares. Right? Even biology. Now, not a very big spelling mistakes, right? You can, let's say, you can change one letter. If it makes sense, then it's okay. I hope that's clear. Now continue, finish writing this.
So, but
Yeah. But
they will cut half marks or one full mark for English.
English half mark.
But Ms. Sujita said that there is no half mark, they directly cut 1 mark.
Now, in English, see, in English, they're going to cut half a mark for each spelling mistake. That is how it works. Now, let's say if you have 1 mark, let's say if you did only one spelling mistake, right? Then that half will round down. Okay. So you only get 1 mark lost if you made 2 spelling mistakes, perhaps. Okay.
Okay. That,
Done. Now, okay, let's look at temperature. Endothermic absorbs heat from surrounding. Exothermic releases heat to surrounding. Okay. Now we look at another example just for this. Let's say the same example which we did. Okay, we have N2 plus 3H2 gives us what? Tell me. Now you need to memorize this, by the way. Which process is this? This is called the Haber process. Now you need to memorize this. N2 plus 3H2 gives us 2NH3, always. You have to learn this by heart. Now we'll do this afterwards. Right now, let's focus on temperature. Now look at this question. What type of reaction is this, Niranjana? Is it endothermic or exothermic?
so what is this time? I always have this down.
Yes, write it over here. In your notebook, write this right here. One more point. Delta H for an endothermic is positive. Any positive number. But for exothermic, delta H is negative. Is that clear? Write this, tell me when you're done.
Done.
Done. Now you tell me what kind of reaction is this? Endothermic, exothermic? Tell me, is it endothermic or exothermic? Can you hear me?
Yeah, sir, the Wi-Fi was slow.
Now you tell me, is it endothermic or exothermic?
It is exothermic.
Exothermic because it's negative. So
Yeah.
exothermic.
So how will we know that it's negative? Will they give it or we have?
They will give in the question. Always. Right? They won't say it's exothermic. They'll just say this much. Delta H is
Okay.
negative. You have to realize it's exothermic. Now, okay. So now we need to realize first that there are two types of reactions happening here. Yes, forwards and backwards. This arrow means forward, and this arrow right here means backwards. Okay. Now the forward reaction over here is exothermic. The forward reaction. But what that really means is that then the backward reaction must be endothermic. Right? The opposite. So if the forward is exo, then the backward must be endothermic. Fine, clear?
Yeah. Not
Okay.
made out.
Right. Write the equation, this equation.
That.
Write this in your notebook.
Okay. So lower. So lower or this one I have to write in these.
This one, decreasing. Now this is the first one, and this is the second one. That is all you have in your syllabus.
Okay.
Okay. Now, have you written this down?
One with I'll write. And the second one. So I have a doubt.
Yes. Ask.
So exothermic is when we release heat, right?
Yes.
So why decrease in temperature is favored?
Right?
So,
Because see, now let's look at that. Why is that happening? Yeah, that's a very good question. Why is this happening? Write it and we'll see why. Because why is not really important. What is important is this happens. I'll tell you why as well. Because if you don't understand, then you can't solve questions. You'll get confused.
Question, what question?
Past paper question.
Uh,
There's only one way to improve, Niranjana. One, uh, let's say, one guaranteed way to improve. That's by solving questions. And it's better if you solve topic-wise questions. The more questions you solve, the better you'll get in IGCSE, right?
okay.
That is that is why that is the whole thing we did back in the day. So most of the students who were weak, all they did was to do more past papers, do a lot more past papers, and they got good marks. So one clear way to increase your marks is by doing past papers, and then ask why, or let's say if you don't understand a question, ask me. Because all of this is okay. You're writing everything down. You're writing the content. You're understanding the content. But if you don't solve the papers, then what will happen is when you get the question, you'll be confused.
Mhm.
Now done writing. Let's look at why this happens. Done.
Yeah.
Explanation. Let's focus on explanation. Now you tell me. Right now, the reaction, the forward reaction is exothermic. Yes. So let's say if I increase the heat here, I'm going to raise a fire. Just a second.
Where is the fire?
Where is the fire? Just a second. I'll show you. This is the fire. Got it? Okay. Now you have a fire here. And what is happening? Now, okay. What is the okay? So what does fire do? Fire increases temperature? Yes.
Yeah.
So what is the opposite of this? What is the opposite of increasing temperature? Tell me. Very simple.
Increase with temperature means heat is released.
Forget all of that. What is the opposite of increasing temperature? Decreasing temperature, yes?
Yeah.
Yeah. So if you increase temperature, then you have to decrease temperature, yes? So the result will be, result is, or let's say action is, opposite action, opposing action, which happens on its own naturally, is decreasing temperature. Now, how can you decrease temperature? Which of these people are decreasing temperature? Which of these feels cold? Does exothermic decrease temperature? Does endothermic decrease temperature?
Decrease temperature, it is endothermic.
Endothermic. Why? Because it absorbs from the heat from surroundings.
Absorbs, yeah.
So that is what this will favor. Now, what will be favored? Endothermic. So increasing temperature. So you have to decrease temperature. So endothermic favored. Make sense?
Uh-huh.
Absorbs heat to decrease. Now you don't have to write this. You have already written this down. Now the next thing is, what if the change, if I make some other change? Perhaps instead of making it like this, what if I, let's say, do this? We got ice now. Instead of heat, let's say we bring ice. Now what is so what will ice do? The change which I'm doing is that ice decreases temperature, yes? That's
Yeah.
cold. So what is the opposite of decreasing temperature?
Increasing.
Increasing. Now you tell me, which of these reactions feels hot and increases temperature?
When increasing the temperature?
Which of these, endothermic or exothermic, increases the temperature?
It will be endothermic.
Not endothermic. Why not endothermic? Because it feels cold. Yeah. I want something which will increase the temperature.
Okay. That means exothermic.
Exothermic. Make sense now?
Yeah.
So, okay. So if I decrease temperature, then the reaction will want to increase temperature. How can you do this? By using favoring exothermic, which releases heat to surrounding. Make sense?
Yeah.
Now, okay, read this once. The change.
Change degree temperature. Okay. Increase temperature, opposing action, decrease temperature. Result endothermic, favored absorbs heat to decrease temperature.
Now this one.
Change degrees temperature, opposing action, increasing temperature, result endothermic, favored releases heat to decrease temperature.
Sorry, not decrease. That's wrong. Obviously, increase temperature.
Then,
Okay, make sense? Any doubts here? Now, this right here, you have to memorize by heart. Okay, these two, 1 and 2, and also these guys, this 1 and 2 of concentration. You have to memorize them by heart because the exact same thing will come in the exam. We'll actually do questions, so don't worry about that. You have to do questions on your own. I'll send you the questions. Now, last thing, pressure. What is pressure, by the way? Niranjana, what is pressure?
pressure, it affects, it's one of the factors that affect equilibrium.
It affects the
Equilibrium.
equilibrium, that's true. But what is pressure, to be very honest? Pressure is, let's
Force
just
over
say,
area.
force over area. Yes,
That's it.
force not into area divided by area. And
Yeah.
pressure is, so in chemistry, let's just say, we can say it in different words as well. What we can say is same as or depends on number of particles. Okay, or number of particles. Is that clear? What is pressure? How many particles you have? Is that clear? Now, if I make, let's say, right now, how many particles do I have in the box?
Two.
2. Okay, I have 2. Now over here, how many do I have?
3.
How many now? 4?
No, 4.
Okay, now what about this one here? How many do I have? On the right.
1.
1. So what happens is, if you decrease the number of particles, pressure decreases. Is that clear? So let's say number of particle decreases. Pressure decreases. Right? Make this diagram on your notebook.
Should I
hope,
make it?
yeah, make the diagram, a rough sketch, write the definition here, or write the change happening.
So I have to make them.
Yes.
So
Yes.
So can you hear me now?
Yes, I can hear you.
I have to make them.
Yes. Actually, before you make them, don't make them right now. Read this first. So read this first. Read this part.
Pressure, number of particles.
Not
in
that
the
one.
spaces.
No, this one. Number of particles.
Number of particles.
Okay, that's pressure. What is that? Tells us
Number.
pressure. Okay, that's how much pressure we have. Now read this.
Uh, so one. That's okay. Particles, number of particles tells us pressure. Number of particles tells us pressure.
Okay, so if you have more particles, then more pressure. Is that clear?
Yeah.
Less particles, less pressure. Yes.
Okay. Yeah.
Okay, now let's look at an example, something which you will be asked in the exam. Again, what is the reaction of Haber process? Write it with me. Say it with me. Read it out.
Haber
N2.
process.
Yeah. N2.
N2 plus 3H2 gives us
Done. Clear.
2H 2NH. I have to learn this equation by heart.
Yes. Yes. This is the easiest mark you'll have in the exam. You have to learn this by heart.
Okay.
There's a lot more to learn to this, actually. I don't think we'll be able to do that right now. We'll do it in the evening. We'll try to finish the chapter as much as we can. Because see, Niranjana, this test you have, we'll give it our all. Yes?
Yeah.
Okay, now this is what we have. Now you tell me, how many particles of N2N do I have? Nitrogen?
2,
2. How many of hydrogen?
3.
Now it doesn't work like that. Why? You have to look over here in the front. Okay, that's the silly small mistakes. Now you tell me, how many particles of nitrogen do I have?
1,
1. How many of hydrogen?
3,
How many of ammonia?
2.
Because look, this hydrogen is actually bonded like this. These are not two particles. These are one particle. Okay, it's a molecule. Nitrogen is bonded like this. That's one particle. So this whole thing is one particle. Okay, this whole thing is one particle. How many of this do we have? We have 3 of these, right? And we have 2 of these. 1 of this, 3 of this. Okay, right? These are the number of particles. Good. Particles. Number of particles. Fine. So far, so clear? Yes? Any questions?
No.
Now change. First thing, I'm going to make you write the thing first, and then I'll tell you why they happen. First, write that's because that's more important. What happens is more important than why. So first, write this down. First thing first. Okay. So pressure, or let's say increasing pressure, favors, or let's say side with less particles favored to decrease pressure. Write it down. Tell me when you're done.
Both of them?
Both of them.
Okay.
Each of these is for 3 marks.
So is it true that we are not allowed to use gel pens or ink pens in the exam?
Say that again.
So is it true that we are not allowed to use gel pen or ink?
Yes, that's true. You can only use ball pens, blue or black, and you're expected to use a blue ball pen, but black is also fine, right? Pencils are also not allowed. Pencils are only allowed in diagrams. If you write something with a pencil, they will not mark it. Just to be clear. If
Yeah,
you're
sir, because one of my senior, yeah, she wrote everything with pencil and she couldn't get the time to erase and write them with a pen, but they took the paper and
right,
then she sent some messages or then so many things happened. Her result came very late.
can I give you write this down first? Talk while you're writing. Yes, are you writing this?
Yeah, I'm writing.
Writing. Okay. I'll give you a secret information. Can I do that?
Yeah.
It doesn't matter. You write pencil with or pen or gel pen. It doesn't matter. Right? They will still give you marks. But just to make things easy for the examiners, you should use the ball pen. Is that clear?
Yeah.
Even if you write with a pencil, and it's actually when you write with pencil, it's harder to understand and detect with the with the scan. They don't check. You should know that they don't check with hand. They check on a computer, like me. So they check on a computer. They scan all your sheets first, and they check on a computer. So
So they
it's
don't go to UK?
they go to UK, but in the UK they scan it. Okay,
Mhm.
okay, and no, always it doesn't always go to UK. No, mostly it does, but not always. Also, yeah, your teachers can
So
just
some
scan it.
say that the papers they come from Jeddah.
Yes, that's true because the British Council in Jeddah. Yes, the papers come to Jeddah from the UK. Then you guys get it from Jeddah.
But last time, Miss Fatima, she was telling some of the papers which were there for their last IGCSE exam was also given in schools in Kuwait.
I see. I see. All right. Now, come on. So write it down first.
Done.
Done. All right. Now, can read it out. Do you have any questions here? I think I've explained it here inside here as well only. Now, if I give you the explanation, let's do the explanation here. And I have the change over here is I increase the pressure of reactants. Let's say, no, sorry, I have to only increase the pressure. You can't increase pressure of reactant or product. Is that clear? Change
Okay.
is increase pressure, either increase the pressure for everything, right? That's how it works. You can't increase, let's say, pressure of nitrogen. No, it works for the whole thing. So how does it actually work? What happens is you have this box. Okay. Now inside this box, I'm going to increase the pressure. Just a second. Now you have to remember that nitrogen is green. Nitrogen is green. Hydrogen is black, and ammonia is orange. Okay. Then I have black particles here. 3 of these. I have, let's say, some of these, and I have, let's say, this guy. Okay. Now you tell me, if I increase the pressure, okay, if I increase pressure, what really happens is, I'll actually just forget this part. Actually, just focus here. If I increase the pressure, what is the opposite of increasing pressure? Opposite,
Decreasing.
decreasing pressure. Now, how can I decrease pressure? Decreasing pressure. You need to realize how can I do the opposite? How can I make that happen? The result of this would be first look over here. Now you tell me which side has a lower pressure, the less particles or more particles?
The right side.
Right side, less particles. Yeah.
Yeah.
So now you tell me which of these sides does on the reaction, the reactants have less particles or do the products have less particles? On the right side, left side we have 4. On the right side I have 2.
Yeah.
Yes. So which side has less particles?
The right side.
So what happens is the in this case the reaction will go forwards. Why? Because result is favor side with less particles. Why do we do this? Why do we favor side with less particles?
Why?
To do the opposite. What is the opposite? To decrease pressure.
Yeah, really.
Because I wanted to increase pressure, now I'm decreasing it. In the same way, what happens if I, let's say, do this? And Niranjan, rejoin for a second. This is the last thing we're doing, right? I'm restarting the meeting. Niranjana, can you hear me?
Yes, sir.
Now, last, which is Haber process. We'll write the definition of this. Not really definition, just the conditions and contact process. We'll look into it in more detail afterwards. But in the exam, you need to know the conditions. Those are easy marks. Now, just a second. I'm giving this down to you. Okay, so write the equation. The equation is for Haber process N2 plus 3H2 gives us 2NH3. Okay, now that's done. Now conditions. Conditions are you have 450 degrees Celsius and a pressure of 200 atm, and finally a catalyst, which is are you writing this down?
Yeah, I'm writing it. Shouldn't I write it?
Write it, yeah. Iron powder.
So always it will be this.
Always this, yes. Memorize it and you'll get always. So see, it's always like this. Yeah, if you can memorize the and understand the concepts, then you can answer the question. Now that you can't really answer
So what
question
is
just by
ATM
understanding.
here in chemistry?
Atmospheric pressure, atmospheres. Atmospheres. So 200 times the pressure of your atmosphere. 200 times. Right now you're in your room, right? You're feeling a pressure on your body from the atmosphere. The pressure for this reaction is 200 times that. Write this down and we're done. Quick. 10.
Catalyst is iron.
Catalyst is iron, yes.
Yeah, done.
Done. Good. Now just a second. Fine. The last thing we have is the source. Source of the reactants. Write this down. Nitrogen is from air, and hydrogen, H2, or hydrogen gas is from methane. Is that clear? And please write this down as well. Now, if you can memorize all of these, you can answer almost all questions in the exam. We'll practice that later.
So I have to write this one also.
Yes. Now this one will come sometimes, not always, but it will come. Yes, it does.
So your voice lagged.
Now can you hear me?
Yeah, now I can.
Right. So you need to know this. How do you get hyd? This is for methane, right? This is called methane, CH4. You should know this in the exam. Write this down. And yep, we're not really explaining any of this. I'm giving you the important things.
So again, your voice is lagged.
Now can you hear me?
Yeah.
Write it down. That's all you have to do on the board, whatever you have.
Okay. Done.
Done. That's a good job. Now start writing about the contact process, which is the final one. This is the contact process. Stop. I'm still finishing it. Just give me 1 second. 450. This will be 280 ATM. Okay, and right. Just a second. Now please write this down. The conditions. And just this.
Atmospheric pressure will be 2.
2, yes. Right, writing that down. And the final thing is S plus O2. You have the in front of all these stages, write their equations.
So here the temperature will be same as for
Yes, same.
degrees.
It's always 450.
For both.
Both, yes.
Only the pressure changes and the catalyst.
Yes. Okay, and this right here, we have SO3 plus H2SO4 gives us H2, H2O7, oleum. And then finally, we have H2, H2O7. Done. That's everything you need. Right now, if you can memorize just these things, you'll get very good marks if you practice after this, right? So this is everything you need to know. Now, after you know everything, you have to prepare by practicing, rehearse, right? Before you do some, let's say, a performance, or before you go to a match of basketball, you prepare your shots. You don't directly just understand how to shoot and then you just shoot. No, before you go to your basketball matches, you practice. That is what we do in studies as well. We do papers, we practice questions, so that we are ready to see what kind of questions may come. But you can't really do questions unless you understand how to do it. That's also useless. You have to do both, right? I hope that makes sense. Now, please write this down, and that is all for today. Stay for a second after you finish writing.
Sir, I was going to say that.
Now, that's for stage 4, right? You know that. Okay.
I will write everything.
Yep. This is everything they can ask you on this, but they will also ask you some theory questions, which we haven't done for contact process. We'll do that with these 2 questions later, and we'll look at nitrogen fertilizer in the next class.
Yeah, so then we will finish the portion by Saturday.
Yes, we'll finish the portion today, and then you have tomorrow and day after tomorrow, I think, to practice past papers, right? Because yep. We'll practice some questions in class as well. Yep. On Saturday. Is that okay if I have an extra class on Saturday?
No, sir, it's okay.
Right? Right? It's okay. Sure. Now Niranjana is trying hard. That's good.
I don't want her to eat my brain. That's it.
Say that again.
Mama is eating brain, that's all.
And now we're just trying to do so much, right? That may be a bit difficult, but you can do it, right? That's why people are telling you to do it.
So what is oleum?
Oleum is this guy, H2S2O7. You don't care what it is. This is what it is. It's basically when you join sulfuric acid and sulfur trioxide, you get this. I will do this in theory afterwards, what this is. All you need to know is that oleum is H2S2O7. How do you get it? You get it by reacting SO3 with H2SO4 in the third stage. Yes. Now, these don't focus on this. You should focus on this because this will come in the exam. But please focus on this guy here, the equilibrium one, right?
Oh.
Yeah, the equilibrium one and this one, the last one. These two. All of these are important. Yeah, they do come in the exam, so you need to know all of them. But start with, make sure that you know the reversible reactions, right? Those are the main parts. I'll upload the recording for this class right now. Okay, if you want to revise it or something, or if someone else wants to see it or revise, you can share it.
Done.
Done. Perfect. All of it is done. Okay. Just a second. Right. Yeah, that's all for today. Now we look at Haber process, nitrogen catalyst later. We look at what are we looking at in the next class? Next class. Haber all the processes, Haber process, contact process, partial questions, and nitrogenous fertilizers. That's all.